so we're looking at solving systems by graphing. So the first thing is we got these blanks to fill in on our notes. So a system of linear equations is either two or more equations. That's all it takes for it to be a system. So again, system is just two or more equations. Again, we're dealing with linear equations right now. A solution of the system of linear equations is where the two lines intersect. So again, where those two lines cross is the answer or the solution to the linear equation system. Where those two lines intersect, we call it the point of intersections, or POI. That's also interchangeable, POI, with point of interest. Not always just is it an intersection, but it can be where things change, things cross. So POI, you see in later math classes as point of interest. It is the same thing as the solution of the system, where these two lines intersect. And then if we have no solution, that means the lines are parallel. The lines are parallel, meaning they never cross, or they never intersect. Right? Can't have a solution if the lines don't cross each other or intersect with each other, so therefore they are parallel lines. And the last one, a system of equations has infinitely many solutions when the lines are the same line. Okay. Meaning you have basically, or essentially, two equations that are the same equation. Right? So we'll see all of those in action. So here's kind of our key concepts down at the bottom, kind of giving it to us in graphical form. So if we have two lines with different slopes, those two lines will intersect each other. So they give us an example of that. So again, different slopes, the two lines intersect. So there is one solution. Okay. If we have the same slope but different y-intercepts, again, same slope, different y-intercepts, our lines are going to be parallel. So the lines are parallel. And there is no solution. So there is no solution. And then our last one, same slope, same y-intercept. The lines are the same line. So there are infinitely many solutions. So again, same slope, same y-intercept. They are the same line. And there are infinitely many solutions. So let's look at a few examples by graphing. So our first example says solve by graphing. We've got two equations, or we've got a system of equations. We've got y equals 3x plus 2. And we have y equals 3x minus 2. So off the notes that we just took, without even having to graph this, what do we know about these two lines? They're parallel, right? They have the same slope, different y-intercepts. They're parallel, so how many solutions are we going to have? 0, right? They're not going to cross each other. There's not going to be an intersection. So they're not going to have any solution. We still need to graph it though. So our first equation, we have 3x plus 2. So that puts us on the y-axis at a positive 2. Our slope is 3. So we're going to go up 3 to the right 1. All we need is 2 points to draw a linear line. Okay. So there's that. Our next equation says y equals 3x minus 2. So this time our y-intercept is at negative 2. Again, slope is 3, so up 3 to the right 1. Not the straightest line. But there we go. There's our parallel lines. Again, they don't cross each other. There is no intersection. So there is no solution. So if we look at B, we have y equals negative 3/4 x plus 3. And our second one, y equals negative 3/4 x plus 3. What do we know about these two lines or these two equations? They're the same, so how many solutions are we going to have? Infinitely many, right? They're the same line, same equation. So once we graph it, we're at positive 3. We have a slope of negative 3/4, so we're going to go down 3 to the right 4 units. There's my line. Of course, my other line is just right on top of it, because it is the same equation. So this is infinitely many solutions. I forgot to write down on the first one, parallel, so there are no solutions. We don't have to put that they're parallel lines, we just need to put no solutions, infinitely many solutions. So let's look at C. This one we have y equals x plus 2 and y equals 2x plus 1. By looking at those equations, how many solutions are we going to have? 1, right? We have different slope, meaning they're going to cross at some point. We're going to have at least one solution, or we're actually going to have only one solution because they are linear. So let's graph it. First one, y equals x plus 2, so we're at positive 2 on the y-axis. We have a slope of 1, so we're going up 1 over 1 each time. So there's my line. Our second equation, y equals 2x plus 1. So we're on the y-axis at a positive 1. We're going up 2 over 1. So there's my line. So again, the point of intersection is our solution to the system of equations. Well, they intersect at point 1, 3. There's our solution. Let's go ahead and do D. We got D equals y equals negative 1/2 x minus 1, and y equals x minus 1. How many solutions are we going to have on this one? 1. So what's our y-intercept on our first equation? -1. What's our slope? -1/2. So we're going down 1 over 2. Down 1 over 2. Again, whenever we're graphing this, say we're going to go off the graph, we can also go the opposite direction, right? We can go up 1 to the left 2, right? Our slope is -1/2. But if it was going to take us off the graph, we can also go the opposite direction. We go up 1 and to the left 2. That is still on that line that we were drawing. Okay. On our second one, we have x minus 4. So again, our slope or our y-intercept is at -4. Our slope is 1, so we're going up 1 over 1, up 1 over 1. So what is our solution? 2, -2. Okay. So that is solving by graphing. So go ahead and look at your homework for solving systems by graphing. We got 10 problems on that. Let's go ahead and look at one of the problems on the back page. And you can pick any of those because this time they're not giving it to us in slope-intercept form. So we need to change it or manipulate these equations to put it into slope-intercept form. So pick one. Which one do we want to do? Anybody? On the second packet. So this is on our solving systems by graphing. Is that second? So pick one of those 5 through 10. Pick a number and I'll do it up on the board with you guys.
Number 9.
Number 9. So number 9, we've got x plus 3y equals -9 and 5x minus 3y equals -9. So first thing we need to do is we need to rewrite these into slope-intercept form. So in order to do that, we have to solve for y. Right? So on our first equation, we want to subtract x over, so that's going to get us 3y equals -x minus 9. And then to get y by itself, divide by 3 on everything on that other side of the equation. So that's going to get us y equals -1/3 x minus 3. So there's one of our equations. Then we also want to solve our second equation for y. So it would be the first step to solve our second equation for y. Subtract our 5x over. That gets me -3y is equal to -5x minus 9. And then again, same thing. We want to divide by that -3 on everything on that other side of the equation. So that gives us y equals positive 5/3 x plus 3. Now we have them both in slope-intercept form, so we can graph it. How many solutions am I going to have on this one? 1, right? They have different slopes. We have 5/3 and -1/3. So they're going to cross. Let's go ahead and do our first one. We have the y-intercept at -3. We have a slope of -1/3, so we're going down 1 to the right 3. Or we can go up 1 to the left 3. Again, that's that same line. Our our second equation is 5/3 x plus 3. So we're at positive 3. If I go up 5 and to the right 3, I'm off my graph. I can't do that. But I can go down 5 and to the left 3. Again, that's still on that same line. So where's my intersection point at? -3, -2. Okay. So that is solving our systems of equations by graph.